So we know vectors have two components, a magnitude and direction. So I mentioned earlier, velocity. So for example, of a velocity would be like 5 kilometers per hour due north. Okay, so velocity has a speed and a direction. So that 5 kilometers due north represents a vector quantity. Displacement, I could say 10 kilometers due east. So that has a magnitude and a direction. So that is a vector quantity. So it's like a distance with a direction. Okay. Do you know what the units for force are? What are the units for measuring force? Yes, I think newtons. Yeah, that's what you mean. I think newtons. So that is actually a vector quantity as well. So force. So this one, an example would be 7 newtons, and just give it a direction. Due west. Okay. So you see this. I think tomorrow when we start mechanics, newtons is a unit. Are the units for measuring force? Units for force. Magnitude is called scalar quantity. So the 10 kilometers is a scalar, 7 is a scalar, 5 is a scalar. So scalar quantity is just an ordinary number. Speed is the magnitude of the velocity, distance. Okay. Directions. Okay. Normally, the I vector represents the direction to the east. The I vector. So it represents the direction to the east. The J vector, because it's upwards, we take it to represent the vector to the north. Okay. I'll go through an example. A girl walks 2 kilometers due east. Okay, so she starts from the point O. So the girl starts at the point O. She goes due east, this direction, arrives at the point A. She has traveled 2 kilometers due east. So that's 2K. Then 3 kilometers due south from A to B. So she goes down south to the point B. So this is 3K. Find the total distance traveled. Okay, so the total distance traveled. Okay, it's not Pythagoras because she has walked 2K plus 3K. So the total distance traveled is simply 2 plus 3, which is 5 kilometers. Okay. Find the position vector of B relative to O. Okay, there's B. This is where she ends up. So O to B, you go 2 to the right and 3 down. So remember, in this situation, we take the I vector to be due east. And we take the J vector to be due north. So in this case, she's gone, so we can say the vector OB has gone 2 to the right, so it's 2I, but she's gone down, so it's negative 3J. So that's the position vector of B. So its position vector is from the origin. Any questions so far? Okay. Remember the magnitude, so this means the magnitude of the vector, how big it is. So you just do Pythagoras on it. So you want to know how long it is. So Basically, you just do Pythagoras on the components. It's the square root of 2 squared plus minus 3 squared. 9 plus 4, root 13. So root 13, if we look at it as a decimal in kilometers, 3.61 kilometers, rounded to 3 sig fig. Okay. The bearing of B from the origin. Okay, bearings are always measured clockwise from the north line. So from O, so you need to imagine the north line here. Okay, so that's the north line. Bearings are measured clockwise from the north line. So this is the angle you want. This is where B is located. So you've got to add 90 plus this angle here. So to answer part D, you need to calculate then this angle. You just use trigonometry. Tan theta equals 3/2. Okay, so inverse tan it. Inverse tan gives you 56.3. Then to get the actual bearing, you just add on 90. So the bearing they want, the bearing of B from O, you just do 90 plus 56.3. 146 approximately. 146.3. That's your bearing. In orienteering exercise, a cadet leaves the starting point O and walks 15 kilometers on a bearing of 120 degrees to reach A. So that's how you start it. So first of all, you need an origin. Okay, so put my origin here. This is my north line. Okay, walks 15 kilometers on a bearing of 120 degrees. So remember, bearings are measured clockwise from the north line. So this angle is going to be 120 to the point A. This is 120 degrees. So bearings clockwise from the north. And that distance is given to you as 15 kilometers. Okay, to the first checkpoint. A cadet, soldier. Let's imagine this is David. From A, he walks 9 kilometers on a bearing of 240 degrees to the second checkpoint. Okay, so let's imagine the north line again. Okay, bearings are measured clockwise from the north, so we want 240 degrees. So this is 180, so that's going to be over here somewhere. Okay, so that angle is 240 degrees. Okay, so 9 kilometers on a bearing of 240 degrees. Okay, so from A, so that's 240 degrees. We know this is 9 kilometers, and this is the point B. Okay, from B, he returns directly to O. So the return journey is back to O. Okay, let's make it look a bit better. Hold, whatever. Okay, so the cadet goes back to base. Okay, so that's the path of the cadet. Okay, you want to find the position vector of A relative to O. Okay, so this is where it gets tricky. Position vector of A relative to O. Okay, so if you think about it, O, if you look at the vector O to A, it's sort of like, and we know this is 15. So we want to know how far along and how far down to go. Okay, that's the idea. So we should be able to figure out some angles. If we know this angle is 120 degrees, then this middle angle here, 90 plus 30. So this is 30 degrees. Okay, so we can figure out then how far along and how far down to go. Then we can express, then we can find the position vector of A relative to O. So we need to know how far along and how far down. So this we can just use trigonometry. So you can see that x over 15 is cosine 30. So x equals 15 cos 30. That's in the I direction. Okay, y is opposite the angle. So you can say y over 15 is sine 30. So we can say y equals 15 sine 30. So that's in the negative j direction. So that's how far along, and this is how far downwards you go from O to A. So if you work these out on the calculator, 15 cos 30, if you do on a calculator, is about 13.0. You round it to the right. 15 sine 30 is 15 times a half, which is exactly 7.5, but it's downwards. I'll be right. In terms of I and j, it's minus 7.5 j downwards. Okay, so that is the position vector of A relative to O. Complicated? Manageable. Any questions? Okay, so it's about using the diagram efficiently, correctly. Okay, next part, you need to find the magnitude of the vector OB. Okay, so to find this, you want the length of this, so you can do some trigonometry again. Probably looks like the cosine rule. Okay, from the diagram, we can get some angles going. Okay, so we know this is 30 degrees here. This is 90. This is 60. So the angle inside the triangle, 300, this must be 60 as well. Okay, so to find the vector, so to find the magnitude of the vector OB, we can use the cosine rule. Okay, so for part B, to find the length O to B, you just stick the numbers into the cosine rule formula. 15 squared plus 9 squared minus 2 times 15 times 9 times by cos 60. Okay, then you square root all that as well. That's the calculation. That's what they've done in the book. So you're going to end up square rooting 171. Which is about 13.1 kilometers. Any questions on that cosine rule? Okay, part C, the bearing of B from O. Okay, the bearing of B from O. So we're looking at O, so we want the angle from the north. So that's the angle we want. Okay, so that angle, that whole angle is going to be 120 plus the angle inside the triangle. So we can call this angle here theta. Okay, so the bearing they want, so the answer is going to be 120 plus the angle theta, which we calculate inside the triangle. Okay, so it's always from the north. So the triangle at this angle theta, we could use the cosine. We can use the sine rule because this theta is opposite 9. 60 is opposite. Okay, this one we should use root 171 to be precise. Okay, so if we use the sine rule, so by the sine rule, we can say sine theta over 9 kilometers is equal to sine 60 over the exact value of OB is root 171. Okay, so we can use that sine rule equation to find the angle theta inside the triangle. So you can check that. Into a calculator, it's about 37 degrees. Okay, and to answer the question, the bearing of B from O, bearings are measured clockwise from the north, so we want all of that. So it's 120 plus 37. So the bearing, the answer to the question, the bearing they want is going to be 120 plus 37, which gives you 157 degrees. Okay, so that is part C, sine rule. Any questions? Okay, part D, position vector of B relative to O. So this is similar to part A. You need to know how far to the right and how far down you go from O to B. Okay. Position vector of B relative to O. Okay. Okay, so if you look at O to B, so O to B is sort of in this direction. We want to know how far to the right and how far down. Okay, so if you look at the picture, the angle, so we know the angle inside the triangle is 37, so that has to be 67. 30 plus 37 is 67. Okay, we know that O to B is exactly root 171. So we need to know how far to look to the right to go and how far downwards to go. So we just use some trigonometry. Okay, so you can work that out. So we can say x over root 171 equals cosine 37. You can say y over root 171 equals sine 67. Okay, so if you work that out, that will give you how far to the right and how far down. So at the end, once you work out those numbers, you can write down the final answer for the vector b. Okay, so if you work out x, you get about 5.1. So this is to the right. If you work out y, 967 times root 171, you get 12.1. So that's moving downwards. We write it minus 12.1j. So that will be the position vector of b relative to O.